So back in your journals here, after create, we're going to have what we need to do to write the rule. Oops, why am I doing 3 there? 2. So if they give us a image that has been dilated already, what do we do to figure out how much that was dilated? I did, and then I tried to cross it off, okay, but you can still kind of see it.
Well, I went to write 3 and then write on one.
I know. I don't know why I wrote 3. I was just so happy.
But it's one of those that
I just got line happy, making straight lines.
he's just an awesome one.
Yes. Here, I'll take my fancy correction tape and get rid of that line. There we go. Mostly got rid of the line. All right. So if we are going to write a rule, what we want to do here is we are going to pick one point to look at, kind of like we did with translations. So we're going to pick one point and its prime. Now, because we're going to be multiplying here, we don't want to be multiplying by 0. So, as a rule, we do not want to pick points with 0 as a coordinate. Oh, what did I do? Hit the wrong button. So, on the piece of paper that I gave you here, if I look at Q, Q is on the x-axis, and so it's going to have some 0 coordinates, so I probably don't want to use those. P is also going to have some 0 coordinates. Once we go through this, you can see that I could use those, but it might be better to not use those because I'm going to need something that doesn't have a 0 as one of my coordinates. So I'm going to pick the R and the R prime. So R prime has the coordinates here of, and then this one, it's like over 1. It's not all the way over to the second one. It's right in the half part there. So R prime is 1.5. And then I went down 2. So 1.5, -2. And R was 1, 2, 3, and down 4. So those are my points for both the R prime and the R. So then my next step here is I am going to set up a ratio of, and we're going to kind of do this in steps here. So the first thing that I need to do is the ratio is going to look like this. It's going to be R prime over R. So this is how we're going to get that, is it times 2? Is it times half? What is, how big or small is it getting? But I don't have to do it for both points. I only need to do it for one part, either x or y. Okay, so I don't need to do the x and the y. I just need to pick the x or the y to do it with. Now, the other part is, if you notice, when you guys were working on that homework yesterday, we didn't have any scale factors that were negative. Like, there's not a negative scale factor. So it's always going to be positive. So if we go all the way back to last year when you guys were 7th graders, one of the very, probably about November, talked about was absolute value. Absolute value meaning it's always positive. It's how far away it is from 0, not necessarily positive or negative. And the way we represented absolute value was with those straight up and down lines to say we want that to just be the positive. Doesn't matter if it's negative originally, we only want it to be positive now. So then, once we get there, what that's going to look like is, I'm going to go back to my problem here. So I need to pick either the x or the y to set up this ratio, the absolute value of r prime over the absolute value of r. I could do it with either my x or my y. Doesn't matter which one I pick. However, when I look at these, the x has a 1.5 in it. And I don't really want to have to deal with a decimal and a ratio because I can't have a decimal and a fraction, and I'd have to try to do something about that. So I'm actually going to use the y values here for this. Because I don't have to use both. I can choose which one I want to use. So the prime value there of the y was -2. And the original value of the y was -4. So then, again, absolute value. I don't want the negatives in there, okay? Because that really doesn't have to do with scale, a scale factor. We don't worry about negatives there. So the absolute value of -2 is +2. Absolute value of -4 is +4. And so far, that is what my scale factor should look like. But I've got one more step. What do you think I can still do to this 2/4? There we go. I can still simplify that. So my last step that I'm going to do is simplify. Ooh, that was too much. Simplify the ratio if possible. It might not be possible. Okay? So remember that we don't, what we just said, want decimals. We don't want decimals or fractions in the ratio. The ratio itself can be a fraction, but we don't want like a fraction in the numerator and a number in the denominator. So if we can't reduce it, we can't reduce it. That's fine. It can just stay the way it is. So, do we have anything that divides both 2 and 4? 2. So I could divide the top and bottom by 2 here to simplify that fraction, and I get 1/2. Can't simplify it anymore. If I divide by 2 again, I'm going to end up with a decimal. I don't want that. So this is my dilation ratio. So I would say, get up a little bit here. Ooh, that was going the wrong way. I am going to dilate by 1/2. And that makes sense that the original, or the dilation there in our diagram is half the size of the original. So that makes sense. So if we double check it, kind of just making sure that I didn't say I was going to take it by half and it actually got a lot bigger, I'm on the right track there. All right, so in your groups, okay, I want you to pick one of these sets of points, E and E prime, F and F prime, G and G prime, or D and D prime, and write out what the coordinates would be there so that we can start to figure out the dilation for that one. So with your group, decide which points you want to use and start writing them down. No, you wouldn't want to do that here. That's actually going to make this numbers bigger. So you become, if there's nothing that divides 3 and 2, you're just going to leave it 3 and 2. Alright guys, so there were a lot of different things that you could have picked here to use to look at for that. When I look at it here, I would probably, I would use G and G prime. That's not the only answer. There's lots of different answers. The only reason I would use G and G prime is because they are exactly on that intersection. I'm not going to have to worry about halves or anything like that. Not that there aren't other points that work, but like, again, just looking at them, that one seems the easiest to me to use. So if I look at that, G is 2, -2, and G prime was 3, -3. Okay? Again, didn't have to be those points. Whatever points that you picked were fine, but you should have picked 2 points So now let's go ahead and set that up, that r prime, or I guess this time it would be g prime over g, absolute value, where you pick one of those coordinates, either the x or the y, that you're going to put into that ratio. So some of you already done it, some of you haven't done it yet. If you haven't done it yet, go ahead and plug that in and see what you get for that ratio. So g prime goes on top of it, which is your negative.
Oh.
Wait, did I actually say that? I did that first. Honors.
Okay, again, for me, the x has all positive numbers, so I'm going to use that one. Could have used the y, didn't have to. But the g prime was 3, and the g was 2. Again, absolute value of positive numbers, they stay positive. They don't jump to negatives. 3 over 2, is there anything that divides evenly 3 and 2? No. If I try to divide by 2, 3 divided by 2 is going to give me a decimal. So that's as far as I can go. Like that, I can leave it 3 over 2. Now I saw some people who changed that to 1 1/2. That's fine. You saw that and that you did that. That's great. But either way, my dilation is 1 1/2 or 3 over 2. And it looked like, as I walked around, all the groups did get that, no matter which points they started with. All right.